Welcome to Strength of Material lectures by Civil Thinking, and today we are going to solve another problem on bending stress in beams. Now the problem is on your screen. A symmetrical I-beam as shown in the figure below is simply supported over a length of 5 meters. Now we have a beam like this, okay? It is 5 meters length, okay? Now the cross section of this beam is an I section, okay? As you can see here, this is the cross section, okay, the cross section of this 5-meter long beam. Okay, now a concentrated load of W newtons is placed 2 meters away from one of the supports. Okay, uh, let us say this is a load of W newtons. It is at a distance of 2 meters. Okay, 2 meters from this left. Let me say this is A, this is B, and this is point C. Okay, it is at a distance of 2 meters from A. Now ignore the weight of the beam. We don't have to consider weight of the beam. We have to consider only load to be W newtons. Calculate the value of load W. Okay, we have to calculate the weight of the load W. Now the allowable stress in the beam is 80 megapascal. Okay, now you see, when you apply this load W on this beam, it will try to bend the beam. Okay, it will try to bend this beam, right? Now because of that, there will be a bending stress, and the maximum bending stress or allowable bending stress, sigma, okay, it is 80 megapascal. Let me say it is 80. Now mega means 10 power 6 pascal. Pascal means Newton per meter square. Okay, what do we have to do? We have to calculate the value of W, right? We have to find the value of W. Now before I move on, I want to tell you, you can download the PDF of this video lecture of this numerical problem of strength of materials from the link in the description. So don't worry about writing right now, just try to understand the concept, and when you understand, you can download the PDF at the end. Okay, now we know the equation, the bending stress equation, which is M by I is equal to sigma divided by Y. Okay, now if you don't know this equation, where did this equation come from, please watch my previous video lecture on bending stress equation, okay, or theory of your bending equation. Now M is the maximum moment, okay, M is the maximum moment. I can also write it like this, M max, okay, maximum bending moment. I is the moment of inertia of the I section. Sigma is the bending stress which is given. Now Y, okay, Y is the distance of this extreme fiber from the centroid. Okay, we will find it later on, don't worry. Now let's first find maximum bending moment. Now as you can see on the screen, this is the beam, right? Now if I draw some lines here, now I have to find the M max, means maximum bending moment. Now we know in a beam, maximum bending moment occurs when there is a change in shear force. Okay, so we need to draw the shear force diagram. Okay, let me say this is shear force diagram. Now if you want to know more about shear force diagram and bending moment diagram, you can also watch my another lecture on shear force diagram and bending moment diagrams. Anyways, now before drawing the shear force diagram, we have to find the reactions. Okay, let me assume the reaction at A is RA, and let me assume the reaction at B is RB. Okay, now we can apply two equations. Summation of Fy equal to 0 means RA plus RB is equal to W. This is equation 1, right? The upward, the sum of upward reactions is equal to downward reaction, okay, which is W. This is equation 1, and we can also apply the moment equation, summation of moment, let me say at moment at B equal to 0. Okay, so we are going to get RA multiplied by 5, right? RA is going to exert a clockwise moment like this, so I'm going to assume it to be positive clockwise moments, and W here you can see it is going to exert moment like this anti-clockwise, and that will be negative. Now RA multiplied by 5, now due to W it is minus W into how much is from here to here. Now total is 5, this is 2, so it is 5 minus 2, which is 3, right? So it is W multiplied by 3, okay, it is equal to 0. So we get 5RA is equal to 3W, or we can get RA equal to 3 upon 5W, right? So RA is 3 upon 5W, right? 3 upon 5W. Now RB, I can find the RB from here equation first. When I put the value of RA here, 3 upon 5, 3 upon 5W plus RB equal to W, right? Now when what is the value of RB? RB is going to be what? I will get this 3 by 5 to the right direction, 3W upon 5, right? So what is the value of RB? It is 5 minus 3, it is 2W upon 5, right? So I get RB to be 2W upon 5, 2W divided by 5, right? Now let me draw the shear force diagram. Okay, now it is 3 by 5W. Let me assume upward reactions to be positive. Let me say this is 3 by 5. Okay, this is 3 by 5W. Okay, now from this is point A, this is C. Now at C there is no load, right? So it is going to be flat. Now here is W downwards. Okay, so I have to go W downwards, right? So already we have 3 by 5. Now we have to go W. Now from here to here it is 3 by 5, but we don't have to go 3 by 5, we have to go W downwards. So how much more we have to go down? We have to go 3 by 5 W minus W, right? Now it is 3 by 5 minus 1. Now I have already shown a video lecture on how to draw shear force diagram, and I hope you know this thing, what I am doing right here, okay? If you don't know, please consider watching my video lecture on how to draw shear force and bending moment diagrams. Anyways, it is going to be W will be common here. This is going to be 3 by 5 minus 1. It is going to be 3 minus 5, which is minus 2 divided by 5, okay? So it is going to be 2 by 5 downwards. Now this much is 3 by 5, it is going to be 2 by 5. Now I understand here will be maximum moment, okay? I know I don't have to draw the this shear force diagram, because now I know this is going to be point where there is a maximum bending moment, because we don't need shear force diagram, we basically need maximum moment, okay? And maximum moment will be where when there is a change in shear force diagram, okay, or when the shear force diagram touches zero line. Anyways, let me first complete this. Now here it is 2 by 5, right? 2 by 5W. Now from C to B there is no load or reaction, so I will go flat. Now at B there is 2 by 5W upwards, so I will go upwards. Now you can see from A to C it is positive, and from C to B it is negative, right? Now at this point the shear force diagram has changed its sign from positive to negative, right? At this point, if you see to the left of this point, it is positive shear force diagram. If you see to the right of this point, it is negative, means this is the point where shear force diagram changes the sign, okay, changes the direction. So this will be the point where there is maximum bending moment, okay? Maximum bending moment will be here. So let's calculate the maximum bending moment at this point, that is at point C, okay? This is the point C. Now let me draw the bending moment diagram, BMD. Oh, let me see, this is the baseline. Now this is the, here the bending moment is 0, okay? Here the bending moment is going to be maximum, here the bending moment is going to be 0, and I will connect them like this, okay? So this is the bending moment diagram. Now what is the value of this moment? This is point C, right? This is point A and this is point B. Now moment at C is the maximum moment. How we calculate the moment? Moment at mx, it is going to be Moment at C, look at this diagram. Moment at C is RA multiplied with 2, right? It is, but RA is 3 by 5 W, right? RA is 3 by 5 W multiplied with 2. Now how much is it? 3 2s are 6 W upon 5. Okay, now this is 6 W upon 5. Now this is the maximum moment. Okay, now what do we need? We need maximum moment, this M max, which is 6 W upon 5, right? This is 6 W upon 5. Now we need I. I means the moment of inertia of this I section, okay? So let me erase this first. Now I. Now you can see this is an I section, okay? Let me assume this to be B, okay? This is B. B is 100 centimeter. And let me assume D to be like this. This is the maximum depth. This is the D, okay? Now B is what? You can see B is 100 and D is what? D is from here top to this, right? It is 15 plus 230 plus 15, okay? Now 15 and 15 is 30. Now 230 plus 30 is how much? 260. So D is 260, okay? Centimeters. Now B is 100 centimeters. Now you know this is a compound. Now you can assume this to be hollow. Now to find the moment of inertia of this I section, we can assume this I section to be a hollow rectangular section, okay? Let me show it here. Okay, now you can assume this I section to be a rectangular section, okay? As you can see, I have drawn the rectangle section. Then in the rectangle section, these two parts are cut, right? This is a hollow part and this is also a hollow part, okay? Here is nothing because I section is this. This is the I section right here, right? This is the I section. Okay, now in the I section, these two are hollow parts. Can you assume this I section to be a rectangle? As you can see, this is a rectangle, right? And the rectangle, there are two holes. So we are going to find the moment of inertia of the rectangle, which is B d cube divided by 12. Then we will subtract the moment of inertia of these two holes, or we can consider these, combine these two holes into a single hole and subtract the moment of inertia of this single hole. Why? How are we going to do that? Because when you have to find the moment of inertia about the same axis, here we have to find, now this I is IXX, okay? Keep in mind, moment of inertia about the x-axis. Because we have to find the moment of inertia of this rectangle about x-axis, we will also find the moment of inertia of these two hollow parts about the x-axis, okay? Now since they are about the same axis, that is the x-axis, you can use the principle of superposition, okay? Now I have told you the rule here. You can just remember this rule and keep solving the problems like this. Now if you want more details on this, you know, the PhD on the moment of inertia thing, you can again watch my moment of inertia lectures, okay? But right now what I am telling you is enough. This is we are finding the moment of inertia about x-axis, okay? We will find the moment of inertia about moment of inertia of this rectangle about x-axis. Then we will find the moment of inertia of these two holes, or we can combine these two holes into a single hole. We are going to find the moment of inertia of this hole or the hollow part about the x-axis. Now since they are about the same axis, that is the x-axis, we can use the principle of superposition to find the moment of inertia of this I section, okay? So moment of inertia of this I section is going to be moment of inertia of the whole rectangle minus the moment of inertia of the hollow part. That will be the moment of inertia of this I section. So let's move on. Now as I have told you, this is B, right? This is B. Let me change the color. Now this is D, right? You know D is 260, right? And B is 100. Now IXX is BD cube by 12. 12 minus moment of inertia of this hollow part, right? Now you can see the width of the rectangle is b. Okay, now if you subtract 10, now from here to here it is 10, that is going to be the width of these two hollow things. Okay, when if we assume that these two hollow parts to be just one part, the width of that one hollow part will be b minus 10 centimeter, right? So b d cube divided by 12, so it is going to be b minus 10 is going to be the width of the hollow part. Of course I have used the minus, right? Now d cube, now what is the depth of this hollow part? From here to here, right? Now from this diagram you will see this is the depth of, okay, this is 230, so it is going to be 230 cube divided by 12, right? Now what is the value of b? It is 100 multiplied by d cube. What is d cube? D is 260, right? 260 cube divided by 12. Now again I will write the value of b to be 100. This is 100. Now 100 minus 10 is going to be 90, right? So I will erase all of this. It is going to be something like this, 90. Okay, now they are both divided by 12, so I am going to take 12 to be common, right? So it is going to be like this. This is going to be 12, and here it is going to be a subtraction, right? Minus sign. Now when you use a calculator, 100 multiplied by 260 cube minus 90 multiplied by 230 cube whole divided by 12, you will get moment of inertia of this I section about x-axis to be, let me use a calculator. So I get ix to be 5521416.7, okay, centimeter power 4. Okay, because this everything is in centimeters, so this will be in centimeter. And remember, the unit of the moment of inertia is length power 4. Okay, why? Because 12 it is unitless, it does not have a unit. Now 260 is length, this is length power 3, and this 100 is length. Okay, this is length power 3 multiplied by length power 3. Okay, so it is length power 4. Similarly, this is length power 4, so this is the reason it is length power 4. So moment of inertia is always something. Okay, now here the unit is centimeter, it is going to be centimeter power 4. If it is millimeter, it is going to be millimeter power 4. Anyways, this is not the moment of inertia class. Now I get this. Okay, now if I convert this into meter, so it is going to be 10 power minus 2 power 4 meter 4. Okay, now 4 multiplied by 2 is 8, so it is going to be 10 power minus 8, 10 power minus 8 meter 4. Okay, now this is the moment of inertia. Now here we found the moment of inertia. Okay, let me make it big. Okay, so here it is 5521416 multiplied by 10 power minus 8, right? Now this is sigma. Sigma is 80 multiplied by 10 to power 6. 80 multiplied by 10 to power 6. Now y is what? Y is the depth of neutral axis. Okay, now from here to here, now let me say this is the neutral axis. Okay, so the depth of neutral axis will be half of the total depth. Now total depth is d, so y is from here to here, it is going to be d by 2. Okay, d by 2 is 260 divided by 2. Okay, 260 divided by 2, which is 130, right? So y is 130 what centimeter? Y is 130 centimeter. Now centimeter is 10 power minus 2 meter. Okay, now this is 6w upon 5, so I can put the 5 here, multiplied by 5. This is 6W. When I solve this equation using the calculator, I will get the value of W. So let me use the calculator. What will be the value of W? So here we go. I found the value of W to be 2831495.7.3. Now what will be the value of W? It is going to be newtons, okay? Because W is in newtons, so here it is going to be newtons, okay? Now when I convert it into kilonewton, it will be 28314, right? Now 123, now 0.9573 kilonewton, okay? Kilonewton. Now when I approximate it, when I round it off, so it is going to be 2831315, right? It's going to be 28315 kilonewton, okay? Approximately. Here we find the value of the W to be 28315 kilonewtons, okay? And I guess the answer was also here, 28315 kilonewtons. So again, our value is correct. Now you can go ahead and download the PDF. And again, if you have any problem, strength of material problem, mechanics of material, engineering mechanics, statics problem, you can contact me in the link. The link to contact me is in the description. You can send me the problem and I will definitely provide you the solution or help you in your doubt, whatever the doubt or misunderstanding you have. I think that's in this lecture. See you in the next class. Thank you.